All right, fifth take. Let's get it. Okay, guys. So, as you can see, we're picking up where we left off. We did voltage dependent sources. I mean, voltage dependent voltage sources in the last video. Now we're doing voltage dependent current sources. As you can see, same rules apply. We're going to have our negative, right here. That's going to our high potential. We're going to have in our positive terminal going to our high potential, right? And the way we're going to, and as you can see, we also have a gain of 5, right? So whatever the voltage difference is across this resistor, it's going to it's going to be multiplied by 5, and that's going to be the current in this wire, right? Because we know um, this wire is just a giant series circuit. This specific wire here is just a series circuit, and we know in our series circuit rules, all the amps are going through it, right? So whatever this amps is here, it's the amp here and the amp here, right? So let me go over here, right? Just to get some practice in. Now, a standard electrical drawing, is going to look like this, right? We're going to have the low potential and the high potential, right? And that's going to be whatever that voltage difference is going to be multiplied by a gain of 5. As you can see, 5 times Vx. The voltage difference across this resistor is Vx. 5 times Vx is going to give us the current flowing through that. All right. So let's go over here now. And first thing we can do is we can start labeling the points that we know, right? So we know ground is going to be 0 volts, right? Of course, because it's ground. And we have a 75-volt battery here, and we know that has a difference of 75 volts between the negative and positive terminal. So if the negative terminal is 0 volts, that must mean the positive terminal has to be 75 volts, right? So this is going to be 75 volts. Let's label that. All right. And let's label our essential node, VA. We have our VA here. Now, we also know the current traveling through this wire already, right? Because of this voltage dependent current source, right? And what is the current traveling through this wire? Well, if I can remember how to get rid of this, well, it's going to be the voltage difference of the high potential, 75, minus the low potential, VA, right? Because that's the voltage difference across this resistor, right? It's going to be the high potential minus the low potential. So we have 75 minus VA multiplied by a gain of 5, right? So let's write that equation. So we're going to have 5 times 75 minus VA, and that is going to equal the current in that entire circuit. All right. So let's start solving. Let's do that. So we can start solving here. Now, the first thing I want to do before we do anything, just so we don't make any mishaps or nothing like that, what we're going to do is we are going to figure out what this equals. So that way we don't confuse ourselves later down the line. So let's do that. 75 VA. Equal that. All right. So now I want to see. So 5 times 75 is going to equal 375. All right. Equal 375. And we're going to have what? Negative VA. Negative 5 VA. Negative 5 VA. So that is equal to negative 5. All right. So we figured that out. Now we can solve for the rest of this problem. So let's do that. Okay. So, all right. So what we're going to do is we're going to find the current across this wire, right? So let's do that. And remember, we got to use our theory where the VA is the high potential for all of this. So let's do that. All right. So we're going to start at ground. We're going to go through the negative terminal, through the positive terminal, right? And we know that's a voltage lift, right? So we have gotten a voltage lift of 75 volts right there, right? And we're going to do Ohm's law at that resistor, right? So what we're going to do now is we're going to do VA, right? We're going to do VA minus 75. Now, I want you guys to be clear, right? Because we're finding the voltage difference across this resistor, right? So why do we have negative 75 here? Well, that's the thing. This isn't negative 75. This is minus positive 75, right? It's just the reason why we're subtracting is because remember, our voltage difference equation requires us to subtract, right? So therefore, this is VA minus 75. But you can't have situations where you have VA minus negative 75, right? You could have those situations. So you guys really need to pay attention to that, just to let you know. And yeah. So VA minus 75, right? And we're going to divide that by 10 to get our current across this wire. So now we have found our current across this wire. So now we're going to move on to the next wire, which is going to be this wire right here. So we're going to find the current across that wire. So let's find that. So we're going to do VA minus. I'm going to go, yep, we're going to do VA minus ground, which is going to be 0. And that's the voltage difference across the resistor. And we're going to divide that by the 15 ohm resistor. And that's, now we have found our current across that. Okay, now we also need to pay attention to this, right? So let's start at ground, right? We're going to start at ground through here, right? And we go through this current source. Now, if we remember anything about current sources, when we travel through them, they're going to be the opposite of the voltage sources, right? So when we travel through a voltage source, positive to negative terminal, right? Because as you know, the top arrow is the positive terminal, and the back side of the arrow is going to be the negative. See, as we travel from positive to negative through a voltage source like this battery right here, we're going to get a voltage decrease. But when you travel positive to negative through a current source, that is a current increase, right? So we got a current increase there. So therefore, this current is going to be positive, right? And we know what this current equals, right? Because it equals this, right? It equals that. So we're going to write that. So we're going to do 375 minus 5 VA, right? And all of that is going to equal to 0. Now let's see, what am I doing on time? All right, oh my God, I'm doing fucking amazing on time. Holy shit. All right, okay, so we're going to 2.0, right? To simplify, so let's start simplifying. So 10 and 15 can both go into 30, so we're going to have 3 plus 2, that's going to be 5, so we're going to have 5 over 30, right? So we're going to have, what is that? If we have 5 over 30 VA, so that means we got to multiply 5 by 30, right? And 5 times 30, that's going to be 150. So we're going to subtract 150 from 5, and that's going to be 145. So we're going to do 145 over 30. Oops. 135 over 30. It's going to be 29. So we're going to have negative VA 29 over 6, right? Negative VA 29 over 6. And that's going to be equal to what? All right, so we have 75 over 10. 75 over 10, that's going to be, what's 75 divided by 5? That's 15. Yeah, 15 over 2. So we have 15 over 2. And we're going to have to multiply this. So 375 times 2. That's 750. So we're going to subtract 750 from 15. 750 minus 15. It's going to be 735. So we're going to have 735 over 2. All right. To be exact, negative 735 over 2. So we're going to have negative 735 over 2, right? And of course, we do 6 over 29. My bad. 6 over 29 times 735 divided by 2. And it's going to give us that, which equals that. So let's see, is that true? So we're going to say 0. VA is equal to 76.034 volts. We're going to say that's positive. Say that's positive. And let's see if that's true. So let's run our simulation here. All right. And that is indeed true. That is indeed true. Where's my calculator? Yep, that is indeed true. And there you go.